Number 63 on page 138, section 1.6, asks us to solve this equation over the real number system. So this has got some not only fractional exponents, but negative fractional exponents. Goodness, goodness, goodness. So how are we going to handle that? Well, I'm going to factor just like how do you solve equations set equal to 0? You factor them and set the factors equal to 0. And to factor, if you recall, when you have negative exponents, or fractional exponents, you always take out the smallest fractional exponent, or smallest exponent, period. So, x, if you recall, when you factor things out, you subtract the exponents, just like, x to the 4th plus blah, blah, blah. If you take out an x squared, it leaves, that's a bad example, x to the 8th. When you take out an x squared, you're left with x to the 6th. Why? You're taking 8 minus 2 gives you 6. So that's what we need to do on this. 3 halves minus a negative 1 half. Well, that is 4 halves, which is squared, minus 10. It's probably going to be x to the 1. These always work out nice. 1 half minus a negative 1 half is 1 plus 25. Sorry, don't put equal sign. I've got arrows here. Okay. Is this factorable? Factors of 5. Yeah, perfect square, I think. So this factors into x minus 5 squared. And then I move this down to the bottom as x to the 1 half. This is a perfect square, or factor it goes into that. So when we get these problems here, anytime you have a fraction equal to 0, you basically ask yourselves, when does a fraction equal 0? Fraction equals 0. It doesn't matter what's on the bottom, as long as the top is 0, the fraction equals 0. So fraction equals 0 when the top equals 0 and the bottom doesn't. So when x equals 5. That's it. I actually don't have to check my answer here because I didn't square both sides, nor did I multiply both sides by a variable expression.